Okay, so in this video, I want to do a couple of things. One of the things that I want to do is sort of make what we're doing maybe a little more general, because what happens if I want to change the -2 to a -3, then there could potentially be a whole lot of things that I want to change. Um, that's one of the things that we're going to be looking at throughout this video. I also want to show how we can add labels, how we can add grid lines, and then how we can kind of make, what if I wanted to go from -2 to -1.75 to -1.5. In other words, what if I wanted these to be a distance of 0.25 instead of a distance of 0.5, or a distance of 1 instead of a distance of 0.5. And same thing for the y-axis as well. Okay, so this is what we have so far. And then I also want to show maybe like there's particular points on the curve that I want to plot specifically, maybe all of the points corresponding to like integer values or something like that. So that's another thing that we want to look at. So the first thing that I'm going to do is I'm going to define a variable called xmin, and that's going to be -2. Xmax, that's going to be equal to 2. And then I'm going to be using a range, and so I'm going to have my step size, which I'm going to use as h. That's typically used as a step size. For now, I'm going to say my step size is going to be equal to 0.1. And so x is going to be np dot a range going from -2. And remember, I need to add the step size there so that I include the last one, and h. And when I plot this, I don't think anything is going to change in this diagram right here. And as we can see, the only thing that does change is it looks a little pointier because maybe my step size is too small. So I'm going to say 0.05, so twice the number of points. Okay, so this looks a little bit better. Okay, but now the reason this is good is what happens if instead of going from -2 to 2, I want to go from -3 to 1.5. So I'm going to run this again, but now on the bottom, instead of going from -2 to 2, it'll go from -2 to 1.35, or sorry, 1.5. Oh, you know what? Sorry, that's embarrassing. This should be xmin, and this should be xmax. Okay, so now when I run it, this is what I'm going to get. It goes from -3 to 1.5. All right, now the next thing that I want to do is, let's say that instead of counting up by 1, let's say I want to count up by 0.5. So the way that we do this is we tell PLT where we want the ticks to be on the x-axis, basically. So we're going to use this command, plt.x ticks, and now we're going to give it another vector, like a list, like these x and y vectors, list, whatever you want to call it, array, that tells us where we want the points to be. So let's say we want the points to go every 0.5. So I'm going to do np.arange. The leftmost is going to be xmin. The rightmost is going to be xmax. But I need to do xmax plus, I'm going to say x step, which I'll need to define what that is, and then x step. So up here, I'll come and say x step is equal to 0.5. Okay, so now this vector right here, given my values of xmin, xmax, and x step, should be like -3, -2.5, -2, all the way up to 1.5. So now when I plot this, I should be a -3 there. There should be a -2.5, a -2, a -1.5, a -1, a -0.5, 0, 0.51, 1.5 when I graph this. And we can see that is what I get. Okay, let's say I'm happy with the y-axis over here. I could do something similar if I wanted the y-axis ticks to be different. And now let's say that I want there to be the grid lines. So I want to have like, vertical grid lines and horizontal grid lines. To do that, we just do ax.grid true. And when I run this, it should give grid lines. Okay, good. So it gives me the grid lines there. Okay, now let's say, so I'm looking over the points, I'm looking at the function sine of pi x. Well, there's some sort of important points that we like. For example, we like the ones that are sort of multiples of pi over 4. So I'm going to say in, and I want to do, let's say I want to do orange dots at those points. So in in is going to be equal to, I want it to go from my x min to my x max, and I want all of the sort of quarter integer. So I want to look at like -3, -2.75, and so on and so forth. So in then is going to be np dot a range, my x min, my x max, and this is why we like a range, because I'm starting at x min and I want to go up by 0.25, so 0.25 here. Okay, now I want to plot that, so I'm going to come down here and I'm going to show you a little shortcut, ax.plot in, and I could come up here and make a new y vector that says, you know, y in is equal to sine of in, but I can just do that all down here. So np dot sine of np dot pi star x. So I'm just gonna plot this and see. I'm just gonna keep it like this and see what happens. It should basically not look any different than what we already have, except this doesn't work. Oh, sorry, I put an x there. It should be an in. Okay. Oh, so it is plotting right on top of it. Sorry. Yes. Okay. So now, let's say I want green zeros, or like green dots. So to get a dot, you just do a quote and an O, and I'm going to run this. Okay. Notice it's putting dots there at all of that. That's sort of, you know, for whatever reason, these are kind of special data points, and so I'm putting dots there. If you want the color to be a different color, you could say color is equal to, let's see if maroon works. I mean, it's a good Aggie color. Okay, so we get maroon there as well. Okay, and you can use hexadecimal code if you want to as well. So I could do something like 010101, and I'm going to get this right here. If I do, let's see. Different colors, different codes are going to give me different things there. Okay. I guess I could do something like, well, whatever. All right, so on and so forth. All right, so I don't want to do too much of that. If I want a different shape instead of an O, I can do a star, and I'm going to get stars there. If I want little triangles, I can do the up caret. Where did that go on my keyboard? Something like this. I mean, I don't know what other things we can do. I don't know if this will work or not. Let's see. It does. I assume if I do less than, I'll get something similar. Okay, so there's a lot of stuff that works. I think even like x's are going to give me x's. If I just put a D there, I'm going to get a diamond. If I put an F there, okay, it doesn't know what F means. So the point is, you can look this up on the website, all of the different things that the plot function can do. Okay, so now we have something like this. Okay, so now let's say we want to set some labels. Like I want to say what the x-axis is, I want to say what the y-axis is, then I want to put a title. So here's how we do that. All of the functions have very the names of the functions indicate what they do. So set x label, and I'm just going to say x-axis, ax dot set y label. This is y-axis, and now ax dot set title, and I'm going to just say y is equal to sine x. When we start looking at LaTeX, we'll see more like a more mathy way to write this. It'll be in kind of a more standard math font. But when I run this, I should have something under here that says x-axis, something here that says y-axis, and a title that says sine, y equals sine of x. So I'm going to run this, and then this is exactly what we get. Okay, so that's it for this video. I think the last thing that I want to talk about today will be how to include like two different plots in one figure. So let's say I want to have y equals sine x here, and then y equals cosine x here. That's what I'm going to show in the next video.